Hello, yeah, welcome back. All right, so we're looking at static electricity in this video. Okay, now what is static electricity or electrostatic? Right now, a static electricity is a type of electricity that is generated by static charge. Okay, a static charge. So anytime we speak of static electricity, it is being generated by a static charge. And of course, what's a static charge? A static charge is a stationary charge. So it's either you call it static charge, right, or stationary. That simply means that the charge, okay, is immobile. So unlike what you have in current electricity. Okay, so unlike what you have in current electricity, that the charge in current electricity is mobile. Okay, it flows through the conductor. All right. So now, how is this static charge generated? How is static charge itself generated? So all static charges are generated by friction. Okay, why? Because you were told, okay, in chemistry that atoms is neutral, but when that atoms actually gains charge, an atom can actually gain charge either by losing or gaining electron. Okay, so every substance is made up of atom. Okay, every substance you ever come across, be it metal, whatever it is, whatever material it is made up of atoms, right? So a situation where I bring two different substances and I I bring two different substances together. Okay, I take one, let's say this is a rod, then I rub it on a sphere. Okay, for a very long time. Okay, and they are two different materials. Now I should expect that at the end of the day, one of the substance should be positively charged, okay, while the other should actually be negatively charged. Why is that? Okay, so please take note. Um, anytime an atom gains electron, it becomes negatively charged, while the one that actually loses electron becomes positively charged. So which simply means that if I rub this rod with this probably metallic sphere, okay, if it happens that the rod transfers electron and the metallic sphere actually gains it, all right, then you discover that the rod will become positively charged while this sphere becomes negatively charged. Okay, so that is how uh, static electric charge is being generated, and that there are two types of static electric charge. We have positive, I already mentioned that. Okay, positive, and of course negative. All right, so now we're going to be looking at the fundamental law of electrostatics. The fundamental law of electrostatics. What is the fundamental law of electrostatics? Okay, according to the fundamental law of electrostatics, we are told that like charges, like charges actually repels. Like charges repel. Okay, why unlike charges? When you bring unlike charges, when you bring them close to each other, what happens? They will attract. So what does that simply mean? If I should bring a positive charge, okay, close to another positive charge, what do I expect? The force between these two charges is going to be that of repulsion. They will repel themselves. But if it happens to be a positive charge and a negative charge, okay, the force that you're going to see is between these two charges is going to be an attraction. So they will attract themselves. All right, so please take note. So that now leads us to what a law known as Coulomb's law of electrostatic force, Coulomb's law. Okay, Coulomb's law of electrostatic force. Now, according to Coulomb's law, he stated that the force of attraction, okay, or even repulsion, depending on the charge, between two charge, okay. Let's say I have two charges of quantity. The first charge is of quantity Q1, right? Of course, and I have second charge of quantity Q2, and two of them are being separated. The distance between the two charges is R. Okay, according to Coulomb's law, Coulomb's law stated that the force of attraction or repulsion, of course, depending on the type of charge, whether they are positive or even whether they are like charges or unlike charges. So the force of attraction repulsion between two charges, okay, is directly proportional to the product of the two charges. That's Q1 times Q2. And inversely proportional to the square of their distance apart, which of course is R squared. Okay, and of course you know very well that in mathematics, if I should replace the proportionality by an equal, I have to introduce a constant. Okay, so going to be K Q1 Q2 then divided by R squared. Of course, you know what Q1 is. Q1 is the first charge, Q2 is the second charge. Okay, R is the distance between the two charge, the distance apart. All right, then where the K here is, this is the electric force constant. Okay, the electric force constant. So it's a constant. Now, for the fact it's a constant, okay, it will always have a constant value. Okay, so let me the constant value K, according to Coulomb's experiments, okay, is equal to 9 times 10 raised to the power of 9. Okay, and of course the SI unit is going to be Newton meter square. Newton meter square per Coulomb square. All right, so that is the value of K. Now the question: how did Coulomb actually arrive at this value, this K, this electric force constant here? How did he get that? Okay, now this K, he got it from this relationship. K is equal to 1 all over 4 pi, then epsilon 0, or absolute epsilon 0 is the symbol of this. This is 4, this is pi, is a constant, and that's another constant, okay, known as epsilon 0. That's what we call that constant, but you can use E. Okay, the symbol, the name of the symbol doesn't matter. Now, but the question is, what is that constant and what does it mean, right? The epsilon 0. So this epsilon 0 is a constant known as the absolute permittivity, or the permittivity of free space. Permittivity of free space. And it has a constant value of 8.89, okay, times 10 raised to the power of minus 12. All right, of course, we'll get the SI unit, or I will derive the SI unit later. Now, so what is this permittivity of free space? Okay, so what Coulomb is considering is that these charges, okay, these charges are actually found in a free space. A free space is a region where there is no material medium, okay, like let's say paper, okay, paper, oil, whatever material medium. So it's looking at these charges being, okay, in a free space, and the free space offers some level of permittivity, okay, to the attraction between these two charges, and it's a constant. All right, and that constant is 8.89 times 10 raised to the power minus 12. Okay, what is the whole idea? The whole idea is I want to show you how, Okay, this particular constant 9 times 10 raised to power 9 being the first constant, okay, came about. By the time you put all this value, okay, which simply means that if I should, okay, put all this value into this expression, which of course is going to be 1 all over 4, pi is approximately 3.114, and of course multiply by this 8.89, okay, 8.89, all right, then times 10 raised to the power of minus 12. Okay, you can do that by yourself. By the time you evaluate this expression, you discover that what you have as an answer will be approximately 9 times 10 raised to the power 9 Newton meter square. Okay, so that is how this constant came about. So we see invariably now, okay, according to from Coulomb's law, let me clean up. Okay, so Coulomb's law, we got this formula: F is equal to K Q1 Q2 all over R square. Since K already we know is K is equal to 1 all over 4 pi absolute permittivity or permittivity of free space. So I can also express the force, electric force between two charges to also be equal to Q1 Q2. Okay, then of course divided by 4 pi epsilon 0, then multiplied by R square. So I hope that is well understood. Okay, so let's look at some typical example. Let's solve some question. Okay, let's look at a situation where you have two charges, 2 microcoulombs and 3 microcoulombs, separated by the distance, okay, in the space, the distance in the space by, let's say 20 cm, and you have to evaluate the force, electric force between these two charges. So we go straight to our formula. Electric force is going to be KQ1 Q2 all over R square. Okay, so let me start. So here we go. So electric force is going to be equal to, my K is 9 times 10 raised to the power of 9. Okay, Q1, or better still, let me go this way. F is going to be equal to, my K is 9 times 10 raised to the power of 9. Okay, then Q1 is 2 microcoulomb. I have to convert that, okay, to coulomb. To convert micro to coulomb, I have to multiply by 10 raised to the power of minus 6. Then times Q2, the second charge, which is 3 microcoulomb. I'll still need to convert that by multiplying by 10 raised to the power minus 6. Okay, so I now have to divide by the distance. The distance is 20 cm, and I have to convert 20 cm to meter by divided by 100. If I divide 20 by 100, I have 0.2. So that's going to give me 0.2, okay? And not forget it's being squared. All right, so let's work on this now. All I'm just going to do is to multiply 9 times 2, then times 3. I divide by what I have here, then I treat the powers of 10 separately, okay? Of course, let's do that now. 9 times 2 is, of course, is 18, if I'm not mistaken. Then 18 times 3. Let me get a calculator. All right, so here we go. 9 times 2 times 3. That's 54. Then, of course, I divide 0.2 square will give me 0.04. So I divide by 0.04. What do I have? I have 1350. This is just for the, don't forget I have the powers of 10, right? So times 10 raised to the power. How do I work with the powers of 10? It will be easy. Okay. Of course, in indices, these are indices, they have the same base. The base is 10. So all I just need to do is just to add the powers. So I'm going to add 10 minus 6 minus 6. Okay, so here we go. This is going to be equal to 1350. 9 minus 6 minus 6, that's going to give me, okay, that's going to give me minus 3. Okay, so of course you know very well that 10 raised power minus 3 is something as 1 all over 10 raised power 3. Okay, these are simple indices. This is something as expressing 1350 times 1 all over 10 raised to the power of 3, which is 1000. Okay, if I divide this by 1000, I'm going to have 1.350 Newton. So I hope that is well understood. Okay. All right. So that is how you evaluate electric force between two charges. Now, let's actually proceed. I'm going to look at, okay, a very important principle known as the principle of superposition. Superposition. When do you apply this principle? Okay, when evaluating electric force. And what's this principle? Now, when we have more than one electric force, okay, acting on a charge, it's possible for more than one force to act on a charge. For you to get the resultant force on that charge, we apply the principle of superposition of electric force. Okay, principle of superposition of electric force. The principle of superposition of electric force states that electric force can be added vectorially if there are more than one acting on a charge. Okay, for example, let me give you a typical example. Let's say I've got a charge Q1. Okay, let's say it's separated by a distance of okay, R1, okay, from charge Q2, and of course charge Q2 is separated from a distance R3 for charge Q3. All right, and I'm being asked to find the electric force on Q2. Let me call it F2. The electric force on Q2. Okay, so the electric force on Q2 is going to be due to the force, okay, of attraction or repulsion due to Q3, and the force of attraction or repulsion due to Q1. Okay, because it's not only Q3, Q2 is actually having influence. The influence on Q2 is not just due to one charge. Okay, it's due to these two other charges, Q3 and Q1. All right. So invariably now, if I want us to find the total force acting on Q2 or the resultant force acting on Q2, is going to be the force, okay, on charge Q2 due to the presence of Q1, then plus the force on the same 2 due to the presence of Q3. So that's going to be, total force is going to be F21 then plus F23. So for example, now let's say what Q1 here is 2 microcoulombs. Q2 is 3 microcoulombs. Well, Q2 is 3 microcoulombs, pardon me. Q3 is let me still use 2 microcoulombs. 2 microcoulombs. So, and the distance R1 is 10 cm. This is also 10 cm. I have been asked to find this F2 now, the total force on charge Q2. All right. So F2 is going to be equal to, first of all, I need to find F21. So let's start with F21. The force on charge Q2 due to charge Q1. And of course, F21 is going to be from Coulomb's law, that's going to be KQ1, then Q2, okay, divided by R1 square. Okay, so let's evaluate that. You know what that's going to be? That's 9 times 10 raised to the power of 9. Then multiply by Q1. What's my Q1? That's 2 microcoulombs. 2 times 10 raised to the power of minus 6. Then multiply by Q2. Q2 is 3 microcoulomb. That's 3 times 10 raised to the power of minus 6. Okay, divided by that distance, 10 cm. Converting 10 to meter, that's 0.1 meter. So I have to square this. Okay, of course, you know what I'm going to do here. 9 times 2 times 3, that's 54. So 54 divided by 0.01. Okay, that should give me 55400. Okay, then of course the powers of 10 raised to the power 9, that's gonna 10 raised to the power 9 minus 6 minus 6, that's 10 raised to the power minus 3. So if I divide this by 1000, I'm going to have 5.4 Newton. So F12 is 5.4 Newton. Okay, so having done with F12, now let's now evaluate F23. F23 is going to be equal to, of course, that's going to be K Q2, okay, Q3, then divided by R3 square. All right, so let's see how that goes. This is gonna be equal to 9 times 10 raised to the power of 9. Of course, Q2 is 3 times 10 raised to the power of minus 6. Q2 is 2 times 10 raised to the power of minus 6, right? Okay, then divided by the same, that's 0.1 square. So it's the same with this. So whatever we have, we still have, give me the same answer. That's F23 now we still yield, okay, 5.4 Newton. So if that being the case now, remember the total force now on F2, which is F2, is going to be equal to the force F2, force on F2 due to force on Q2 due to the Q1, then force on 2 due to Q3, right? So that's going to be 5.4, then plus 5.4. And if we should add that up, 5.4 plus 5.4, what do I have? 10.8. So that's going to be 10.8 newtons. So that is one example of principle of superposition of electric force. Let's look at another example. Okay, let's see a situation where you have, okay, vertical and a horizontal force acting on a charge. At this point, I have Q1 here, which of course is minus 1 microcoulombs. At this place, I have plus 2 microcoulombs, and the distance apart is 10 cm, and I have Okay, this is Q2. Then I have Q3 right here. Okay, which of course is 4 microcoulombs. And the distance apart is 20 cm. So the question now is, find the force on Q1. Okay, force on Q1. So the resultant force on Q1 is going to be force due to the, okay, the resultant force on Q1 is going to be the force due to Q2, and I call that F12, and it's acting vertically, okay? Then, and the other is the force due to Q3, I call that F13. So of course, you know, in vectors, vector addition, okay, when the two vectors are perpendicular, for us to be able to add the resultant of this force on Q1, okay, it's just gonna be this this line that is cutting the F1, that's cutting F12 and F13. This is gonna be my resultant F1, resultant of the vertical force and the horizontal force, okay? By the, of course, with treated vectors, you know that that's what we do when two vectors are perpendicular to each other. And how do I get this F1, this resultant? Remember, we use Pythagoras rule. So that means the resultant F1 now is going to be equal to the square root of the, of course, the horizontal force, which is F13, then of course square, plus the vertical force F12 square. Okay, and you know very well that the resultant, the resultant have a direction theta, which you know how we get. For us to get that direction of the resultant with the horizontal, okay, we're going to evaluate the tan inverse of the vertical force, which is F12 divided by the horizontal force F13. Okay, so let's get to this. First, let's find F13. Okay, let me start with F13 first. Right, okay. Of course, F13, you know how we get that. That's going to be KQ1, Q3, then divided by R13 square, okay? The distance between Q1 and Q3, right? So that's, I use R13 to represent that. All right, so now let's start putting our value. K is 9 times 10 raised to the power of 9 times Q1. Q1 is negative minus 1, okay? Then of course times 10 raised to the power of minus 6. All right, then multiply by Q3, 4 times 10 raised to the power of minus 6. Okay, so when you divide that, you have to divide that by the distance. That's going to be 0.2 square. Okay, so let's flow. So what we have here, 9 times minus 1 minus 9 times 4. Okay, so that's 36. So I'm having minus 36, of course, divided by 0.04. Divided by 0.04. Okay, I made a mistake. That's, yeah, 0.04. I'm on a track. 0.04. That's 900. 900. Okay, I'm having minus 900. Of course, that 900, don't forget the powers. If I evaluate the powers of 10, I'm going to have 10 raised to the power minus 3, okay? So if I divide 900 by 1000, I'm going to have 0. So I'm having minus 0.9 Newton. Okay, so let's go to the other force, F12. F12. F12, how do we evaluate F12? Of course, that's going to be K, Q1, Q2, then divided by R12 square. The distance apart between Q2 and Q1, that's what R12, okay, represent. So let's put our values. So there's going to be 9 times 10 raised to the power of 9. Then multiply by Q1. Of course, that's C going to be minus 1 times 10 raised to the power of minus 6. Then Q2 is 2 times 10 raised to the power of minus 6. Divided by the distance. The distance is 10 cm. So I'm having 0. Please pardon me. I'm having 0.01. Okay. Okay, 0.1 square. Okay, let's work on this now. This 9 times 1 minus 1, right? Minus 9 times 2 minus 18. 18 divided by 0.01, that's 1800, 1800. Of course, that's still negative, right? Then times 10 raised to the power of minus 3. And when you do this, you're going to have minus 1.8 Newton. So I've gotten everything I need now. So I can now apply my Pythagoras rule, okay, up here. So let's work on this. There's going to be square root of F13 square, which we evaluated to give us minus 0.9. So minus 0.9 all square, then plus F12 square, that is minus 1.8 all square. Okay, so calculator will help us work on this. 1.8 square, what do I have? That's 3.24. Of course, minus, when you square minus, it will give you plus, right? So I have 3.24. Then, of course, 0.9 square should give me 0.9 square. 0.81, right? Plus 3.24. What do we have? 4.05. So I have approximately 4.05. Square root of 4.05. And when you find the square root, you will have 2 Newton approximately as the resultant force acting on Q1. So if you know how to apply vectors, okay, if you know how to work on vectors, you can apply the law of the principle of superposition. Okay, we just the same way we find the resultant of forces in vectors. That's what we do uh, uh, in the principle of superposition of electric forces, right? So that is just it. Okay, so we're going to look at more questions in the next video. See you in the next video. Thank you very much.